Somewhere in the African Savanna, a cathedral is being built, one blade of grass at a time.
No hands, no tools, no blueprint. Only instinct, pioneering intelligence.
The weaver bird, a creature no larger than your fist, is one of nature's greatest structural engineers. What they build defies what modern engineering says should be possible at this scale.
A single nest can contain over 1,000 individual knots, each one tied with a beak.
Today we go inside to Mandit, to understand how this miracle of organic architecture is actually built. Before the first blade of grass is gathered, the weaver bird faces its most critical decision: where to build.
The branch must be slender enough to prevent snakes from crossing.
Overhanging water is preferred, a natural moat that makes snake approach nearly impossible.
The male will sometimes strip nearby leaves from the chosen branch, removing all cover and making any approaching predator immediately visible.
This level of environmental assessment, predicting threats before they occur, represents forward planning once thought exclusive to humans. With site secured, the male launches into a gathering frenzy, slicing grass blades with surgical precision. Each blade is assessed for length, width, and flexibility before selection. Rejected blades are dropped instantly. A single nest requires between 300 and 500 individual strips of grass, each transported one at a time.
Some species use other materials, strips of palm leaf, thin bark fibers, even spiderweb silk as structural binding.
Spiderweb silk provides the tensile strength no plant fiber alone can achieve, a material 50 times stronger than steel by weight. Construction begins with the anchor ring, the single most critical structural element of the entire nest. From this ring, the bird builds downward, weaving a dome-shaped outer shell that distributes weight evenly across the entire structure. The beak acts as both needle and hook, threading, pulling, and locking each strand with 2 to 4 deliberate movements. The knots used by weaver birds include the half-hitch, the slip knot, and a unique overhand loop that human sailors independently invented thousands of years later. The beak acts as both needle and hook, threading, pulling, and locking each strand with 2 to 4 deliberate movements. Within the dome, the bird begins interior division, weaving partition walls that will separate the entrance tunnel from the main living chamber. In some species, the tunnel extends downward by up to 6 centimeters, longer than the nest itself. And tartan cliates. The interior is lined with soft feathers, plant dars, plant down, and vine and grasses.
The entire structure, from foundation to lining, is completed in as little as 9 to 14 days.
But a single nest is only the beginning. Weaver birds build not just homes, they build cities. The social weaver of southern Africa constructs the largest nest of any bird species on Earth. A permanent apartment. These structures have stood for over a century, weathering storms, droughts, and generations of occupants without structural failure. Inside the communal nest, individual chambers maintain different temperatures, a natural HVAC system engineered from thatch and air pockets. Outer chambers can be up to 10 degrees cooler in daytime food, used for resting during heat. Inner chambers trap. Other species move in without invitation, pygmy falcons, barbets, and even cobras using weaver nests as their own permanent housing.
When the male's nest is complete, he hangs upside down at the entrance and calls. The female will come, and she will be merciless.
The female enters the nest and inspects every chamber, every knot, every joint.
If the nest fails inspection, the female simply leaves. The male must tear the entire structure down and begin again.
A single male may build and demolish up to 25 nests in a single breeding season before one is accepted.
This ruthless quality control ensures that only the most skilled engineers reproduce. Evolution.
But the fortress is not impenetrable. The boomslang's snake, slender, patient.
Some weaver nests are deliberately built near active bee or wasp nests. A biological alarm system no predator will approach twice. During heavy rain, the nest's tightly woven exterior becomes effectively waterproof, water beading and running off the angled exterior without penetrating. Even in fierce savanna wind, the hanging nest acts as a pendulum, swinging to absorb energy rather than resisting. This pendulum principle, absorbing rather than resisting external force, is now used in the design of earthquake-resistant skyscrapers worldwide. Architects and materials scientists have begun studying weaver bird nests as models for sustainable, low-energy building construction.
Their knot structures are being replicated in flexible robotics, machines that can tie secure load-bearing joints without mechanical fasteners.
Their thermal management system, the layered chamber design, is being studied as a model for passive cooling architecture in hot climates. Each solution different, each one perfect, each one the product of millions of years of trial, error, and the relentless pressure of survival. The next time you walk beneath a tree and see a hanging ball of woven grass pie, stop, look closer. Built by a creature with no hands, no language, and no tools, only the accumulated wisdom of 10 million years of knowing exactly what to do.